Assalamualaikum and a very good day everyone. So today we are going to learn two rules in analyzing the circuit. First is the voltage divider rule, or I call it VDR. So voltage divider rule is used to determine the voltage across one resistor or loads, one or more loads in a series circuit, series, without knowing the current. Okay, VDR is used in a series circuit without knowing the current, provided that the voltage source is being given. For example, this circuit, this is a series circuit. We have voltage source and the resistor is in series, right? So how to find the voltage divider rule equation? This is how it being derived. First of all, we are using the KVL here. Okay, so we know here is negative V plus V1 plus V2 is equal to 0, right? And if we rearrange it, we can get this equation, V equal to V1 plus V2. And by using Ohm's law, we know that V equal to IR, so we change everything here, V1 and V2, into I multiply with R2, I multiply with V1, I multiply with R1, and V2 is I multiply with R2. And then this R1 and R2, we sum it up and we get Req here. Right, so the current here is equal to V equal to Req. Okay, this is not the voltage divider rule. This is how the voltage divider rule being derived. Okay, don't get confused. This is how it being derived. Okay, I want to show you guys. I haven't showed the correct equation yet. Okay, so we have this is the equation number 1. So for example, if you want to find the voltage across this R1, okay, this particular R1, so V1 is equal to IR1. This is Ohm's law, we know that. So how is we include this V equal to Req into this equation? Okay, so we get this equation. V1 is equal to V divided by Req multiply with R1. So this is VDR. Okay, this is VDR equation. If you want to find V1, so V1 is equal to V multiply with R1 divided by these two summation of resistor. Okay. Okay, now how it benefits us by knowing that VDR. So this is very beneficial if we having a bunch series of resistor. For example, we have like 12 resistor, for example. So if we want to find this resistor here at the voltage here, we no need to find the current across this anymore. We just using this equation directly. So V here is equal to source voltage multiply with the resistor here and divide with all the numbers of resistor here. Okay, simple, right? Okay, now I want you to test your understanding. So we have this circuit, we have 3 resistors here. How to find the voltage across this resistor? Okay, how? Firstly, you need to find the equation of this VDR. So which one is the correct equation? A, B, C, D. Which one? You need to know first. And then after you know the equation, you need to put in all the numbers here, the value here. So R1 is what, R2 is what, and then V is what? V is the voltage supply. And then you directly can find the answer. Next rule. is the current divider rule. Just now is voltage, now is current divider rule. So current divider rule is used in a parallel circuit. For example, consider this circuit. We have two resistors here. There is current going through R1 and current going through R2. And we have voltage source here and we have the current source here. So what is meant by current divider rule? It is used to determine the current through a branch, any branch in a parallel circuit, without even knowing the voltage. Okay? For example, this equation. So how we can know this? We can derive the equation. I will let you know. Okay, this is how. Firstly, we are using the KCL. Okay, KCL at this node. So we know that this current in is equal to I1 plus I2 current out. And we also know that in a parallel circuit, the voltage here is the same. V here is the same as V1, R1 here and R2 here. Okay, remember this is a parallel, so it's the same. Okay, as you can see here, the voltage is the same, so we can deduce that I1 is equal to V over R1. Okay, for this branch, I2 is equal to V over R2. Alright. This is very simple because there is no resistor or element here beside the V. So that's why we can get directly the I and I2 here. But this is not the current divider rule again. This is how it being derived, okay? Want to let you know. Alright, so by knowing this resistor, and then we can get the equivalent resistance. Alright, we are using this equation and we rearrange it, we get this equation. Okay, you might ask how. You need to check your mathematics again. So how is you make the denominator same? So this is R1, so multiply with R2, below R2, top also you multiply with R2. Then you rearrange it and you can get this one. Okay, and by using Ohm's law, we know that V equal to IR, so we add everything here, we put in the value here. Okay, so we can get, alright, so after that we can get this equation. Okay, this equation, and we rearrange everything, and lastly we get this equation. Look how this is Req divided by R1 because we want to find the value of I1, right? Okay, this is simplified version. So if you want to find the current here, we don't need to find the voltage here, no need anymore, because we can use directly this equation. Okay, R2 over R1 multiply with current source, and then you get the I1. Alright, I2 also is same. So if you are having a bunch of parallel resistor, but a lot of branches, so you can directly use this equation to find the current. This is also a current divider rule. So you can multiply with the Req divided by Rn. Okay, multiply with the current source, and then you get the current that particular resistor. And then also you can use the conductance. What is conductance? Conductance is the reciprocal of resistor. G is equal to 1 over R. Okay, so from here we can know if you want to find the current here, the G here, we just 1 over R Rn divide with all the G and multiply with the current source. Okay, for your subject, the branches, usually they will give you 2 branches. So you only need to remember, the first equation that I showed you just now. The I1 is equal to I multiply with R2 over R1 plus R2. Okay? Right, now we need to test your understanding, whether you understand what I'm saying or you just sleeping throughout this video. Okay, so let's find this value of current that going through this 3 ohm. Okay, how is by firstly you need to find the current source first. Okay, if the current source is not being given, usually they give like this. But if they didn't give it, so you need to find the current source first. How? Firstly, you need to find the resistor, the total resistance here. So you need to parallel this first, and then add with this resistor, series resistance, and you get the Req. So how much is the Req? Press your calculator now. Okay, then you get this value, how much? And then the 12 volt divide with this value and you can get the current here. Okay, now you already have the current here, so can you find this current? Of course, by using the equation of CDR, which is the current source multiplied with the different resistor. If you want to find the current here, means you need to multiply with this resistor first and divide with R1 plus R2. Okay, can you get the answer? Alright, thank you very much. That's all for today. See you in the next video.